the following example, we're going to solve for the missing values. So that's going to be our x and our y. All right, so we want to know what x is equal to, we want to know what y is equal to, and we're going to go ahead and just state what these angles actually are. So taking a look at this diagram first here, or taking just a look at these set of lines that we have going on here. The first relationship that I'm going to use in order to solve this is anytime you're given this box that we have here, right, in any kind of drawing or anything like that, that box signifies that that is a 90-degree angle, right? So since this box covers these two lines here, that tells me that any angles within this have to add up to 90 degrees, right? Because this is a 90-degree here notation, so anything within here has to be 90 degrees. So we have these two angles here that make up this little section here. So what that tells me is that this angle over here, which we know is 27, plus this angle over here, which is stated as a 3y, 27 plus 3y, these two angles together have to add up to 90 degrees. So that's what I'm going to do first. I'm going to take the 27 here, I'm going to add it to the 3y, and again, we should know that these add up to 90 degrees because of that notation right there. They make up a right angle is 90 degrees. So solve this for y. That's going to give us our first unknown variable. In order to solve this for y, go ahead and subtract that 27 on both sides. The 27 is going to cancel on the left-hand side. And this is 3y is equal to a 63. Finish solving this equation. We have 3 times y. Opposite of multiplication is division, so divide out that 3 on each side, and we get that y is equal to a 21. So we do know y is equal to 21. So that solves one of our variables for us. We can go ahead and also find the angle measure for this angle right over here. We know this angle here, which is labeled 3y. Now that we know that y is equal to, right, 3y or 3 times our 21, which we now know that y is, and 3 times 21 is going to give us a 63. So we know that this angle right over here is 63 degrees, along with the 27 of this one makes up the 90 degrees for these two angles. Now, in order to find what x is equal to, and then in turn the measure of these two here, right? Whatever x is equal to will be this angle here. And then once we know what x is, we can plug it into this little expression here to find this angle and wrap up the problem. So the rule that I'm going to use for this one here is just the definition of a supplementary angle. Anytime we have a straight line, right, any angles within that straight line make or add up to 180 degrees. So if I can find a straight line here, right, every single angle that I would have within here, whether it's, 1, 2, 10 different angles within this here, but definition of a straight angle is it is 180 degrees. So taking a look at our diagram here, we do have a straight angle. We have this straight line right over here. That means every single angle that encompasses this, right, has to equal 180 degrees, or they have to add up to 180 degrees. I have 4 angles within this supplementary angle. Angle 1, angle 2, angle 3, and angle 4. And just by definition of a straight angle, again, a straight angle is 180 degrees. I have 4 angles within this straight angle. So I'm just going to say angle 1, which is an x, plus angle 2, which is 27, plus angle 3, which is the 3y, but we also calculated and found out that that is 63. You can also call 27 and 63. If you want to add these together and call that 90, you definitely can, because we do know already that these two angles are 90. And then plus our angle 4 over here is the 8x plus 18. All right, so we know that all 4 of these should add up to 180 degrees. Again, just definition of a straight angle. So just doing a little bit of cleanup here, just let's solve the remaining problem that we have here. Let's clean up the right-hand side a little bit, and let's take that x plus 8x. Well, 1x plus 8x is 9x. 27 plus 63 is 90. And then that 90 over here plus this 18 gives us 108. Let's finish solving this equation and let's subtract 108 on each side of our equation. That's going to cancel the 108 on the right, letting us drop down that 9x. 180 minus 108 gives us a 72. And then let's go ahead and divide out our coefficient on each side here, canceling the 9, giving us that x is equal to 8, right? 72 divided by 9 is an 8. So we now know that x is equal to 8. The only other thing left to figure out here is the actual angle measure of this one right over here. And we can figure that out real quickly here. We know that this is an 8x plus 18. So if we plug in 8 for x, that we now know that it is, well, 8 times 8 is 64. And 64 plus 18 there, well, let's see, that gives us an 82 for that angle measure here. So we know that this total one here is 82 degrees, knowing that x is 8. Again, 3y, which we knew y is a 21, so a 63. This one was already labeled 27. This one over here is merely an x, which is 8, right? 8 degrees, which is always why when it comes to the world of trig, geometry, the visual world in math, always go by the numbers and the notations. Never go by what you assume it appears to be. This chunk over here looks like it would be way more than 8 degrees, but based off of the math and what we have labeled here, this piece here is an 8 degrees just by our given values that we started out with this problem here. Otherwise, that's it for this video.